This is the MQ-25 Stingray, a drone set to revolutionize naval combat with its game-changing capabilities. Recent leaked photos suggest it might soon be armed, adding a whole new dimension to its already impressive features. With autonomous takeoff, mid-air refueling, and carrier landing, the Stingray is poised to redefine naval warfare. The stakes are high. This technology could extend the reach and power of naval operations forever. The journey of how the Navy developed this incredible technology began back in the early 2000s when the U.S. Navy started tinkering with the idea of launching drones from ships. At that time, the U.S. Air Force had just introduced the Predator drone, and the Navy wanted something similar for its ships. After several years of planning, the Navy finally set up the Unmanned Carrier-Launched Airborne Surveillance and Strike Program. Each of the major players in the drone market, like Boeing, Northrop Grumman, Lockheed Martin, and General Dynamics, all got to submit prototypes for testing. Initially, the Navy wanted a drone that could be a fully autonomous armed drone that could carry out strike missions alongside manned aircraft. However, after several years of testing with little progress, the Department of Defense shifted the program's goals to focus on aerial refueling instead. This then became the Carrier-Based Aerial Refueling System program. Once this new initiative was established, the Boeing prototypes won the day and became the sole effort of the program. Hence, the MQ-25 Stingray was born. But what exactly is it? According to data from NAVSEA, the Stingray is 51 feet long, just under 10 feet tall, and has a wingspan of 75 feet when fully expanded. However, the wings can fold into just 31 feet because it is stored inside an aircraft carrier before launch. Powering the drone is a single Rolls-Royce AE 3007, which delivers an impressive 10,000 foot-pounds of force. While the exact operating parameters like speed, range, max ceiling, and acceleration are all classified, it is known that the drone's power plant is very similar to the Navy's MQ-4C Triton. Besides this data not being known, it has been publicly stated that the drone needs to be able to deliver 16,000 pounds of fuel up to 500 nautical miles away from an aircraft carrier. But how does it do that? In the world of military aviation, there are two primary aerial refueling methods. The first of these is the boom method, where a rigid steel boom extends from the refueling aircraft and then connects into a receptacle on the receiving aircraft to give them fuel. This method is more popular with air forces. However, navies around the world typically prefer the other method due to size constraints. This method, known as the probe and drogue method, is how the Stingray refuels aircraft. As the receiving aircraft gets closer, the Stingray deploys a flexible hose with a basket at the end. As the receiving aircraft comes near the basket, the receiving pilot puts their probe into it. The hose is then stabilized via a drogue, and fuel is pumped into the receiving aircraft. Once the desired amount has been taken, the receiving aircraft then breaks away. But has the Stingray actually proven it can do such a dangerous and complex evolution? Despite taking its first flight in 2019, by the summer of 2021, the Stingray was ready for its biggest test yet. After taking off from a St. Louis Air Force base, the Stingray held its course over the Illinois skies. Anyone watching from below who may have saw what was going on may not have at the time realized that they were literally watching history unfold. As the Stingray steadied on its course and deployed its drogue, a U.S. Navy F-18 Super Hornet came flying in close behind. Without a beat missed, the pilot connected his probe to the drogue and took on fuel. But the Stingray was not done making history yet. After successfully refueling an F-18, the Stingray also experimented with other aircraft. Next came an E-2D Hawkeye airborne early warning aircraft, followed by an F-35 strike fighter. Because of these tests, not only had a record been set for the first time ever that an unmanned aircraft has successfully refueled a manned aircraft, but the Navy also successfully tested aerial refueling for all primary fixed-wing aircraft in a carrier air wing. And the Stingray was still not done yet. Just a few moments later, the Stingray was conducting another groundbreaking test. With the assistance of a deck-handling operator, the Stingray was maneuvered into position using a joystick-like device. Once in position, it was able to go to different positions on the deck just like any other aircraft could. Though the Stingray did not take off and land, nor has it done so yet, these first tests are important since it has to be integrated with other manned aircraft. But how does the Stingray do that? While the exact capabilities of the Stingray remain a tightly held secret, it has two basic parts: the aircraft body itself and the AI programs on board. Though Boeing has not publicly mentioned how the Stingray can do what it does, the flight characteristics are impressive. With the ability to use GPS and inertial navigation, the Stingray can follow pre-programmed routes worldwide. While airborne, the AI system on board aggregates data from all its various wind, radar, cameras, and other avionics to continually make small adjustments to maintain position. The algorithm can also use real-time data analysis to evaluate other air contacts and threats to the aircraft and take evasive maneuvers where necessary. The AI program on board can also integrate with a wide variety of secure communications to continually send updates back to the aircraft carrier. In addition, the Stingray can continually monitor the health of its own systems and provide updates in real time if there are any problems. Because of all these features, the aircraft can fly pre-programmed maneuvers and perform like any other manned aircraft. But even though the Stingray can do all of this cool stuff, how will it impact naval warfare? The Stingray's effect on carrier air wings once fully operational cannot be understated. As of right now, the Navy has a technology gap in aerial refueling. While F-18s can use a buddy system to refuel other aircraft, this takes an otherwise combat-capable F-18 out of the fight to do so. Additionally, the Navy does have a few C-130s that are aerial refueling capable, but there are not a lot of them and they're not very frequently used. Because of this, the Stingray is a huge asset on a carrier air wing that can ensure the unit has its own organic refueling capabilities. And that potential is endless here, depending on the type of aircraft being refueled. For example, if the Stingray were refueling F-18s, this would increase the range of the carrier strike group's combat power. If the Stingray were refueling E-2D Hawkeyes, this could keep the eyes and ears of the strike open for longer, thereby keeping the U.S. force better appraised of the air and surface picture around them. But that is not the only mission a Stingray can do. Because of the two hardpoints underneath each wing, the Stingray is already capable of carrying a variety of sensors and electronic attack weapons. Jamming pods, signals collection equipment, and sophisticated cameras can all be mounted on board, making the Stingray an invaluable refueling asset and intelligence collection tool. However, aerial refueling and intelligence gathering are not the only missions the Navy has in mind for the Stingray. Based on recent photographs from Boeing, the rumors Navy leadership has briefed Capitol Hill on are true. According to recent media reports, top Navy leadership has been briefing congressional officials on the fact that the Navy is going back to the original program intent of having an armed, autonomous drone. While the Navy acknowledges that the aerial refueling capability is something they definitely want to keep for the foreseeable future, the Sea Service also wants to make an armed version, and a picture from Boeing makes this appear to be true. From Boeing's most recent press releases, these are models of the Stingray that are armed with an AGM-158C long-range anti-ship missile under each wing. This weapon is a replacement for the Navy's aging Harpoon missile and is an extremely deadly, powerful weapon that can reach out and touch a ship up to 200 nautical miles away. But why does this matter? The fact that the Stingray could be armed in the future is a very bad prospect for America's enemies. With the ability to fire a long-range weapon, the Stingray could, in theory, be sent forward like a sacrificial lamb to expend all its fuel on a one-way mission. Sending swarms of Stingrays in this fashion, though theoretically wasteful of a very expensive asset, is a viable tactic in a peer-to-peer conflict where taking out the other side's air defenses from range is the best option. This is because if one side is the first to take out the other side's air defenses, that side's manned aircraft would be at less risk. Of course, this is still all speculation, since the Stingray has yet to be fully operational as an aerial tanker, much less a kamikaze drone. But who knows? Maybe that time will be sooner than we think. Bye for now.